Good evening. My name is Mark Robbins. I'm co-chair of the Green Homes Committee with the Connecticut chapter of the CTGBC, the Connecticut Green Building Council. And I'm also a trustee of the New Canaan Nature Center at the moment with our Sustainability Committee. It was great to see so many faces back again. I thought we would have worn you out by now. This is the third in our four-part series on energy and environmental innovations. Tonight's topic is building energy innovations, intentionally somewhat ambiguous to leave room for creative thought from our speakers tonight. So happy Earth Week, everyone. This is our extension of Earth Day, which was Monday. And I think we've all come here tonight. So I want to make sure everybody's had a chance to give us their email address so we can invite you back. That's the only way we can build our database. I hate to leave people out for the future programs. I want to speak a little bit about Earth Day quickly. That was first celebrated in 1970. It was the idea of Senator Gaylord Nelson of Wisconsin, who was also a governor. And at the time that this concept was conceived, the most prevalent issues were factory pollution, toxic dumping, pesticides, loss of wilderness, and species, animals, plants, microorganisms, basically biodiversity. And those issues were the catalyst for the grassroots movement in the 70s that created Earth Day, and really has forever changed the environmental movement in the United States, and now has been adopted by almost 200 countries as of this year. So to tell you a little bit about the GBC, the Connecticut chapter of the Green Building Council, we're a nonprofit, volunteer-based chapter of the USGBC, which is well known for its LEED program, the acronym LEED, Leadership in Energy and Environmental Design. It's a certification. And the series was really inspired by Connecticut's recent adoption of a comprehensive energy strategy. The idea of this four-part symposium, if you will, was to synthesize the initiatives and innovations from both private and public sectors and really create a platform for regional collaboration among the towns in Fairfield County to facilitate participation and innovate in the innovative new clean energy programs, including those developed by CEFIA and DEEP. So the primer, the first program we had 2 months ago at Lapham Community Center was really celebrating Public Act 1180 and talking about the synthesis of the Department of Energy and Environmental Protection into DEEP, and it was very much the legislative primer for this series. Last month we heard from Governor Malloy and an equally interesting panel at the Christine Wagner Room at the New Canaan High School, and the topic was infrastructure and energy solutions. We heard about microgrids, combined heat and power, how fuel cells play into the mix, and district energy. And tonight we are going to hear from a collection of speakers, very theoretical and all the way down to delivering architecture that is enthalpic and considers energy modeling as part of the design in the beginning. So this is our third segment. Our final one will be sustainable planning next month. And the idea is they're fast-paced talks, sort of like mini TED Talks, if you will, so 10-minute presentations. We try to protect a little Q&A time at the end for the audience to stump the speakers. So I want to start by thanking Laura Heckman, who's here tonight and here always. She's the Executive Director of the New Canaan Nature Center, our host. Judy Swan, the Executive Director, standing at the back, Executive Director for the CTGBC. And yes, we are an official chapter of the USGBC. And especially Joanna Grab, who's here. She's doing all the work and managing our database and making sure everything gets done. She's the Secretary of our committee. And Elizabeth DeSalvo, who is co-chair. I'm co-chair, and she's the more legitimate co-chair. She's actually an architect. and then the folks from DFA, Doug, who's providing the video services tonight, along with Channel 79. So tonight we're going to hear from Doug Heitzman, Director of Strategy, IBM Collaborative Solutions. We're going to go from left to right. That's Doug, and he's also been responsible for repairing and setting up our PowerPoint presentation, so he is an IBM strategist, should be qualified for that. Ron Arugio, who just escaped from interrogatories and the proceedings that are going on at the state level to hone the next 3 years of energy policy. Ron Arugio is Manager of Conservation and Load Management with CL&P and Yankee Gas. And to my right is Mark Schiller, Vice President of Business Development for Proton On-Site. And I'm still trying to understand how hydrogen fits into the mix, and I was very excited to be able to fit him into the panel tonight, and I know I'm going to learn a lot. And finally, Mark Simon, one of the founding partners for Centerbrook Architects and Planners, one of the preeminent and most prolific and comprehensive design solvers, I would say, in the country right now. They've done a whole lot of ridiculously good and interesting work that's energy conscious and good design. So with that, I am going to introduce our first speaker, Doug Heitzman. And Doug is Director of Strategy with IBM Collaborative Solutions. In the capacity, he's responsible for IBM's social business collaborations and portal overall strategic directions. He's frequent industry conference speaker and consults with business and governments all over the world on IT policy standards, open source, talent optimization, and collaborative technologies. Doug holds a Master's of International Economics and Social Administration from the University of Grenoble, France, and a BAH in Political Studies from Queen's University at Kingston, Ontario, Canada. And with that, Doug, and I will start you off. There we go. Okay. And then I'm going to take my name tag.
Super. Thanks very much. Good evening, everyone, and thank you very much for inviting me to come and talk to you. You might be asking, what in the world's, some IBM guy that spends his day job worrying about social business and the like, talking about, residential building. Oh, thank you. And Mark and I have been chatting and working through these various different sessions for a number of months now. We've been throwing some ideas around, and he said, well, why don't you come and talk to us, because some of these ideas are kind of interesting. And I come at this from a slightly different perspective than most of the people that you're probably used to talking to. I am a professional strategist. I've been doing strategy work inside of IBM for the better part of the last 13 years or so. And we view the world through these different lenses. So what are the major disruptions? I'm getting all the fancy transitions out of my system on this first chart here. So we see the world in terms of disruptions, right? So what's going to happen that's going to change the rules of the game and realign different forces? We look at competition, and that can be competition from, in this world, different fuel sources, for example, or different, different political regimes, or different, or different companies. The market maturity and the ability for a marketplace to absorb a new value. What are the various different patterns out there? How do we identify and articulate novel and genuinely new value creation? What are market subsidies? And what I mean by a market subsidy is that if, for some reason, some major investments being made, for example, take all the investments going into cloud technology and mobile technology that are being paid for a whole bunch of other kinds of reasons, what kinds of business models can be built on top of that infrastructure and thus take advantage of the subsidy that that outside investment represents? And then also adjacencies, right? What is adjacent to something that I'm doing so that I can more cost effectively take this new thing to marketplace and I've got permission to enter a marketplace. So these are the major kind of strategic lenses. And so I've kind of taken some of these lenses and applied them to the issue of green residential building. Now, there are some very high-level meta-disruptions that I think we should all keep in mind. Water scarcity is an increasingly big issue, and I'm convinced that sometime in the next 2 to 3 years, we're going to start to see some significant aquifer issues that are going to lead to some real stresses on food supply around the world, and the issue of water scarcity is going to become a big issue. This is the International Year of Water Cooperation for the UN, and I think there's going to be a lot of thinking and a lot of politicization about water scarcity issues. Energy prices, of course, is an ongoing issue. When do we hit peak oil and what are the implications and all that kind of stuff. The overall economic climate, is Europe going to fall down? What's going on with the Chinese real estate bubble? And all of that translates into our regular day-to-day lives in terms of how much money do people have to invest in housing, and what are the mortgage rates going to be, and all that kind of stuff, and how secure are people in the stability of the economic situation. And then finally, there's the whole issue of regulation and taxation, and specifically around carbon and what effectively is an externality, right? So one of the biggest challenges we have as a society, to say nothing of as an industry, is the issue that the major fuel sources that are fueling our lives, so to speak, have some very, very large externalities that aren't priced into the actual commodity. Even a very conservative estimate suggests that if you include the price of some of the fleets that we have to ensure access to oil in the Middle East, and some of the impact of coastal flooding and a few of the other issues that are out there, the conservative issues are that we've got a cost basis of about $12 a gallon. Some more, perhaps even realistic ones that start to take into consideration the implications of climate refugees and destabilization and increased rates of failed states because of falling food sources, then of course the price is going to be a lot higher. And so we've got some really interesting challenges around how do we incorporate some of those externalities into the real price structure so that markets can work properly. So there's some meta disruptions. There are some kind of micro disruptions that are kind of fun and interesting, right? So these are a few that I find kind of interesting. People have invented cement and that self-heals. It's got these little micro spheres inside that have a polymer that when the cement cracks, they crack open and they fill out and they seal the cracks automatically. So self-sealing cement, that's kind of cool. We've got something called liquid granite, which uses recycled materials to create a substance that is actually both lighter and actually has the same load-bearing characteristics as cement without producing all the CO2 that the cement industry causes. There are the materials coming from NASA, like aerogels, that provide insulation capabilities that are orders of magnitude greater than the traditional materials that we use today. There's some new solar cell technology. I'm working with a company in Toronto right now that is producing some very flexible, incredibly thin, put on as wallpaper kind of solar cells, and in fact are working on a paint substance that you could literally paint a house, and with something in the range of 3 to 7% efficiency, your entire house is generating electricity. And the reason that some of these are interesting, are disruptive, is that when you start incorporating into building materials, the cost of doing solar on your house isn't a net add-on to building the house. It's a percentage increase on building materials that you're going to need anyway, right? Put shingles on your roof, you have to pay for them anyway. If they're 20% more costly because they generate electricity, then you can do some mathematics to figure out if that's, makes good sense or not. But it's a completely different kind of math than it takes to figure out if you should go and put traditional photovoltaic cells on your roof. These things in the middle are called sea balls, right? Sea balls are these matted bunches of seaweed that have some really interesting characteristics. They have very, very low salt content and almost no protein in them, so they don't rot. And they have tremendous insulation capabilities. There's companies that are starting to commercialize the use of sea ball as an insulation material in housing. The ability to build carbon fiber structures and then spray them with the various different polymers to set them is a very powerful technology in some areas that are prone to hurricanes and high winds. The glass on the bottom left is a new glass technology that actually monitors dynamically the quality of the air, including the carbon monoxide and carbon dioxide content in the atmosphere dynamically, and puts it out on a readout to give you right now what the air characteristics are inside your house. People are building flexible cement that has some implications in building buildings in areas that are prone to seismic activity. And in the bottom right-hand corner, this I think is interesting. This is something called transparent cement. And what they've done is they've put a whole bunch of fiber optic cables through cement blocks and figured out a way to manufacture these things so that the cement actually transmits a very large percentage of the ambient light. And of course, as you're thinking about designing houses that have thermal masses in them, being able to transmit light through cement walls could have all kinds of interesting impact in terms of mitigating artificial lighting or increasing the thermal mass capture potential of a building. So there are some of these kind of micromaterial disruptions that I think are interesting to watch and to try to figure out which ones are going to be really big game changers. There are a few big game changers out there that I think represent some really interesting disruption. Just 2 days ago, IBM announced that in working in partnership with the Swiss government, under a grant from the Swiss government, at our research laboratory in Zurich, that we've produced a technology that's called high concentration photovoltaic thermal. And this is a very exciting technology because we're getting 80% energy capture efficiency with this technology. And what the reason is that on the raw photovoltaics, we're only getting about 32%, which is pretty much state-of-the-art. But we're using technology we've harvested from building supercomputers and cooling them to capture the thermal component that's naturally wasted. And interestingly enough, out of this system, not only are we getting raw energy out of it, but we're actually desalinating, and we're desalinating water at a rate of about 40 liters per square meter a day. So per square meter of coverage, we have 40 liters of potable water from desalination as a byproduct of this kind of technology. And on top of that, they've gone so far as to use a certain kind of gel material that is introduced into the thermal cycle and provides cooling. And so being able to put these things on top of the roofs of buildings in areas that are, don't have a lot of potable water and are very hot, producing extremely efficient energy, and these interesting things as byproducts are potentially very disruptive, and I think you should give us a lot of hope that there's some interesting things that we should watch out for. The Battery 500 project, I'm convinced that this is a really major disruption. So back in 2009, once we had actually lost out or passed over by the U.S. government that had put out $2.9 billion in grants to develop next generation battery technology, we said, well, we're going to go do it anyway. And we made an announcement about 6 weeks ago that we're quite a ways ahead of what we had thought we were going to be able to get to. This is a brand new kind of battery technology. It involves some very advanced chemistry that we've had to model on some supercomputers. It is a lithium air cell that uses ambient oxygen as the reagent to generate the electrical, the chemical process that creates electricity, and then emits the oxygen back to the atmosphere on discharge. But the bottom line here is that we're going to have, we hope by about 2020, we should have a commercial prototype by the end of this year. We're going to have automobiles, family of 4 automobile, sedan that will have over 500-mile range. We are about 12 to 15 times the energy density of state-of-the-art lithium-ion, which is currently powering the best electric cars that we have. This means that we're having somewhere between 300 to 500 kilowatt hours of storage in a car. Now, this is disruptive for a bunch of reasons. First of all, if the raw efficiency of electricity is about a net equivalent of about 105 miles to the gallon, so it means that we've got much more efficient transportation. But the big thing that I think is really disruptive about this is that suddenly, can you imagine that we've got a number of million distributed 500 kilowatt batteries distributed all over the place? What does that mean for the ability to absorb peak loading off of microgeneration? What does that mean if the utility, at an incredibly reduced rate overnight when it's generating peak capacity out of its nuclear plants, can drop it somewhere and then, under contract, pull it back out of this distributed battery to mitigate peak loading in the middle of the day and avoid brownouts, or spool down some of its overall peak capacity that it has to design into the system because our grid can't support that kind of balancing. Suddenly having millions of distributed high-capacity batteries changes everything. So I think this is a potentially big disruptor, and we see these things coming into commercial use in about 2020, so it's about 6 or 7 years off. Microgeneration, this is an interesting example. Both of these piles, the one on the left is I believe, a Panasonic pile, and the one on the right is, I think it may be an LG, but they're both using a new fuel cell technology from a company called Ceres in the UK. And what they've done is they've used a new process that allows them to build one of these types of fuel cells that runs at, instead of being between 1200 and 1400 degrees, they can run this thing at 600 to 800 degrees. Which allows them to build it on top of stainless steel substrates instead of ceramic substrates, and that dramatically changes the cost equation. And as soon as you change the cost equation, you can scale these things down. These two units, and they're starting to roll them out in the UK, and in Japan they already have 6,000 households with the outdoor unit installed. These are 1 kilowatt hour cogeneration fuel cells. 1 kilowatt hour for one house. Right? This isn't only, we can only scale down to a factory or perhaps a large, community. This is, I can put, in fact, the picture on the right-hand side is inserted into a cabinet wall inside of a kitchen, generating all of the power for a house and generating hot water as a byproduct. Now, what does that mean to, the fault-tolerant nature of our grid as it's increasingly subjected to violent weather events? Right, when you've got distributed cogeneration like that down to the individual household. So that's a potentially interesting disruptor. And I think probably maybe one of the biggest disruptors out there is the cost curve that is allowing for incredibly intelligent network-connected devices. Because intelligent network-connected devices allow us to capture energy. And this is where the strategist in me will kind of lead to, and the chief argument that I'm going to make here. There are all kinds of really low-hanging fruit involved in sealing the envelope of a house, insulating it, changing the windows, etc. I'm going to make an argument that says that the lowest hanging fruit is in removing the latency in decision-making. Right now, we have very crude measurements. I get a bill every month from the electrical company or the gas company that says, this is how much you owe me. But below that, I don't have a lot of visibility to why that is and what I could do about it. I want to see a world where I'll get a note that because the temperature's fallen to 4 degrees outside, that my utility, in order to mitigate some of its peak loading issues, issues me a piece of information that says, by the way, if you reduce your thermostat by 3 degrees, you'll save $40 tonight. Well, suddenly I can make a decision. I can put a sweater on because that's $40 in my pocket. But I'm using that as an example of the power of information to allow people to make highly optimized decisions. Information allows us to profile and to optimize selling, to optimize the use of our resources to get the best payoff. And when we can inform and incentivize individuals to make good quality decisions, all kinds of things change. People start changing their light bulbs, people start upgrading their insulation, people start thinking about building their new houses in new and interesting ways. So that's going to be kind of the chief part of my argument here. There are a few kind of information disruptors. These are the big four that kind of affect my world, and I think that silicon economics is what we kind of call the disruption of the price curve in the IT business, is going to drive into the building industry because it's increasingly going to become about data, and I'll reinforce that argument in a few slides here. But these are the big four things that are colliding in quite a remarkable way to define the next generation of information. And what's interesting is this also becomes a subsidy for your industry, because the investments going on to build out all of these technologies are being paid for externally. The ability to layer all kinds of interesting business models on top of this subsidy is the impact that we're going to see impact the building marketplace. So let me give you a few examples of what I think is going on. Number one, as we become much more sensitive about water, we're going to start to meter it. Intelligent meters for the whole house, discrete line metering, and even discrete appliance metering. Right on the right-hand side of these charts is a water meter built into a faucet, an individual faucet that is radio connected to the network that tells you exactly what's coming out of that faucet, at what point in the day, and how much of it. Right, so being able to figure out what's going on, because by the way, you can then come in and say, you could then make a recommendation that says, if you install the low-flow shower head because of your behavior, this means $18 a month to your bottom line. Well, I can now make a decision. I'm going to go out and buy a low-flow water or a low-flow toilet. Suddenly I can translate these into meaningful, decision-oriented metrics. On top of that, there's going to be sensors embedded in the output, right, in the waste lines to figure out flow of the waste. That, by the way, can give a sewage treatment plant tremendous insight and warning about what's about to hit them so that they can plan appropriately. Right? Or in fact, if they determine that because of some scenario, maybe a big storm's happening or something like that, they can actually make a request to people or incentivize them through incrementally changing their billing such that please don't put on your washing for the next 6 hours or put your dishwasher through or take a shower for the next 6 hours because we're going to reach a peak loading in our sewage treatment plant. We're going to get overflow. We're going to have to dump into the river. We don't want to have to do that. To mitigate that, because you are this kind of customer and you've got these kinds of behaviors and we're monitoring exactly what your effluent flow is, we can tell you, please behave in this way and incentivize you in a way to try to get you to do that. On top of that, we're getting remote actuators, and by the way, these aren't big expensive things, right? These flow actuators are, $3 or $4. They're not terribly expensive things, but that allows you to start turning things on and off, right? So you can in fact set up scripts that detect under certain conditions, do the following things. And when you can actually have data that compares and contrasts the inflows and the outflows, you can start making all kinds of patterns summations. You can figure out that these people are filling up a swimming pool at a certain time of day or in a certain way, or they're watering their lawn in a certain way, and you can start making recommendations and incentivizing people to behave in ways that are more constructive, are more cost-effective, and of course, the more cost-effective we can be, the more capital gets liberated to do more productive things in our economy. Electricity is also getting an awful lot smarter. Of course, we've got smart metering, and right now we've kind of gone to time of day metering, but the next generation of smart metering really gets into dynamically negotiated pricing. Where especially as we get bidirectional flows, whether it's because of microgeneration or because I've got a big battery sitting in my driveway, I'm going to have contracts with my power companies that are going to be very, very discrete, not just time of day. And if they determine that for some reason we've got a heat wave and we need to change our behavior patterns, they can actually negotiate with me to say, listen, I need to buy power from your generation or storage capacity, or I need your appliances to start browning out. I want to cycle down your freezer down to 60%. I'm going to cycle your dishwasher into a mode that'll take 4 hours longer to do but consumes 20% less power. I'm going to do these things, and I'm going to fluctuate the price of the power that I'm both buying from you and selling to you in very discrete packets. So that's kind of on a whole house level. We're also getting much more discrete monitoring and control of individual devices and individual power sockets. I think this one in the middle here with the green band around it's really interesting. This is a metered network internet connected plug that you just plug and you can plug appliance into it. This thing was an idea that someone put up, and it was crowdsourced and crowdfunded at Kickstarter. Right? A whole bunch of people put $5 in or $10 in because they believed this was a good idea. And they got all the funding and they built this. And you can buy them in units, and I'd love to see builders start to actually make plugs that are actually sockets in the wall, perhaps with the green band branding on it to say that this is a smart plug. I can monitor and meter it, and by the way, there is an app that comes along with it that gives you a live view of exactly how many watts are going across that plug. And I can turn it on, I can turn it off, I can spool it down, I can brown it out, I can do all kinds of things remotely from my smartphone. Once again, leveraging the subsidy of the fact that people have smartphones and networks that they bought and paid for other reasons to implement a completely new kind of business model. And then finally, we're getting smarter appliances. And not just appliances that have a screen on it that allow you to look up recipes, but appliances that are smart enough to know that the power rate and the water costs are going to be variable and make intelligent decisions about when to do certain things and which programs and scripts it should follow under different kinds of conditions. And the reason that these things are happening is that the cost of building the smarts into things is becoming a fraction of building the thing. Right? All the cost is in the steel and the bending and the folding and the insulation and the compressor motors. The cost of the brains are incredibly small. And so that's why these things are becoming smarter and smarter. And the real challenge is, how do we leverage this? So heating and cooling are getting smarter. There's both intelligent gas meters and increasingly network-connected intelligent thermostats, right? In fact, the one on the top is the Nest one, the one with the little orange button, and that is not only a programmable network one, it actually monitors your life and is dynamically adaptable. And it's always changing and always optimizing itself based on how it's monitoring the flow of people throughout a house, at what times of day, on what days of the week. And it's always learning and it's always changing. Now, I was talking to Mark a couple weeks ago, maybe it was about 6 or 7 or 9 weeks ago now, and I was saying, you know what, I'll bet you that at some point in the near future there's going to be a utility that stands up and says, you know what, it is worth me giving everyone a free one of those things because of the amount of energy it's going to save. Well, about 6 days ago, I live in New York, Con Edison, strangely enough, just sent me an email saying there's a $300 state-of-the-art intelligent thermostat with your name on it for free. And we're giving them out for free to everyone. We're starting with people who've got central air conditioning because we're worried about our peak loading in the coming summer, because there may, our long-term forecast is suggesting there's going to be some heat waves that are going to really put stress on our grid. And so the first people into the system are people that have large, significant central air conditioning units installed in their houses. And that's what the prioritization is going to be. But we're giving them away and for free. And they're very advanced models, network connected. I can pull out my cell phone, I can see what temperature my house is at, I can change the temperature dynamically, I can see the pattern, I can set up schedules, and I can adapt them, I can change them dynamically. I already have the one down in the middle there, the 3M version. I've had it for years now. And when I travel, I set my house down to 48 degrees. I get to the airport, I get in the car, and I go click, click, and it takes me 40 minutes to get back up to my house. And by the time I get to my house, it's at a nice toasty 64 degrees, and I am happy. I've been doing this for years, and I couldn't think of living any other way. But more and more people are going to start to do this, especially as utilities are giving these things away for free. Remote control, right? In fact, these are some of the interfaces. These are little screen captures of the actual interfaces that I use on my system to adjust the temperature and move them up and down, and it gives me, a demonstration of what my temperature patterns are being, or what my usage model is. Now, that's great on an individual basis and allows me to do some things to optimize my own profile. Can you imagine what happens when that information, which is already up in the cloud, right? Because I'm transmitting it up, my thermostat's transmitting up, if it's aggregated with millions of other people, and utilities and governments can use the insight from all of those usage patterns, time of day, what temperatures, to figure out which houses don't have enough insulation, right? Which houses need window upgrades. The data's there. right? If we capture it and process and use some analytics against it, we can make some much better quality decisions. Insight from aggregated data is really the big panacea here. So, information leads to actionable insight. All these devices are going to be feeding information to the cloud. Utilities and governments are going to be able to take that information and to start doing measurement, aggregation, and analytics, determine usage and patterns, and get insight from that, and develop appropriate policies, programs, and promotions based on information. Billing and guidance information can be distributed to end users and visualized in a way that, first of all, gives them insight about what's going on, and second of all, gives them the ability to interact and control and become engaged. Engagement's a big deal. We need to get people to think they have a stake, think they have control, understand that even though they're one person amongst millions, that they are an active participant and can do something about the bigger planetary picture. But it's only by giving them the tools and the information so they can make decisions that they can actually switch their brains onto the, I can make a difference, I'm part of the solution, and I am engaged in the process. And I am hoping that that, in fact, will change the political climate so that we can actually make some real progress. I can't think of any other really obvious way to engage people in a way that really moves that. So information comes out, but control goes back into the cloud from these devices, allowing people to remotely interacting with all these various different smart devices and control them remotely and monitor them. And, of course, the utility allows, it can then contract and have those bidirectional negotiations back and forth because we've got distributed intelligence in the system. There is power in measurement. This is Miami-Dade. Miami-Dade has got 363 parks and consume 360 million gallons of water every year. This costs Miami-Dade $5 million a year in water bills. Well, we implemented a system, IBM implemented a system at Miami-Dade where we just went around and put water sensors all over the place so we could figure out where you're losing water. And there was water being lost through broken pipes. There was water being lost, obviously, through things like evaporation from ponds. There was also water being lost because there was a broken gasket on a water fountain. The very fact that we could measure what's going on and efficiently dispatch people to go out and fix these things that are broken, instead of letting them be broken for months on end, they're saving $1 million a year. The payback on this was a blink of an eye. And suddenly they've got $1 million in their budget to go and spend on stuff that they couldn't spend it on before. Right? So measurement makes a big difference. Pricing and awareness of the price signal. My argument is that there's tremendous latency in decision making. And part of that is that the price signal and the granularity underneath the price signal is obscured for us. Well, you might know these are Swedish words for before and after. These are pictures. You can see it's scanned in from a newspaper. And you'll see the date stamp on this, right? This is at exactly the same time, 16:30, 4:30 in the afternoon. One was on January 2nd and one was on January 3rd. Both work days. Notice the difference in the traffic pattern. Why is that? Sorry?
They shifted it an hour.
Sorry?
They shifted the time to go to work for an hour?
How? Why would that happen? How can you ship that many people?
Tolls.
Not quite. This was the first day of the implementation of a congestion traffic pricing system. The very first day. And so just the way that we're talking about externalities that aren't priced into things, congestion is an externality. Right? It was inhibiting productivity. It was a lot of wasted gas, pollution, all kinds of externalities. By pricing that in and making that price evident and obvious to people, that is how the behavior changed. You're right, they did start traveling at different times of the day. They went in half an hour earlier, left half an hour later, or carpooled, or took public transportation.
Or they did this via tolls, I imagine?
Well, so there's no toll booths, right? This is all done through, photographs and stuff. It happens to be a big IBM system, but it's a dynamic congestion management system that allows them to charge people during certain times of the day to enter into, because Stockholm is actually a composite of a whole bunch. It's an archipelago of lots and lots of islands with lots and lots of bridges. There's lots of bottleneck points that add to this congestion problem. And so they basically said, we're going to price this, that at certain times of the day between this hour and that hour, and they can change it dynamically because it's all just computers, there's going to be surcharges for entering and exiting the city during certain times of the day. And everyone's happy about it, by the way, because it means that I can get to my office, if I'm willing to pay for it, in a fraction of the time than I could before. Right? And it's just changed everyone's behavior. And they're extremely happy with it. Enormous success. But my point of this is that when you make the pricing signal obvious, all kinds of weird and wonderful things happen. Communications is also important. This is one of the big challenges I think we have. Right? How much is 758,302 kilowatt hours? Is that a lot? Well, it happens to be for 479.938 pounds of carbon dioxide. I don't know, is that a lot? Well, this is an email I got on Earth Day. I got this email on Earth Day. I'll read this for you because I know it's small. It says, Earth Day 2013. IBM is committed to environmental leadership in all of its business activities, from its operations to the design of its products and use of the technology. IBM's global environment management system is a key element in the company's efforts to achieve results consistent with environmental leadership and to ensure the company is vigilant in protecting the environment across all of its operations. To mark Earth Day 2013, please take a moment to learn about IBM's environmental programs, reflect on how you contributed to our recycling and energy conservation initiatives in 2012. Recycling initiatives at the Somers location, which is where I work, resulted in 168.08 tons of material being recycled in 2012. This equates to the following natural resource savings: 2,857 trees, or 336.16 barrels of oil, or 689,128 kilowatts of electricity, or 1.176 million gallons of water, or 504.24 cubic yards of landfill space. Energy conservation activities and initiatives at Somers resulted in 758,302 kilowatt hours saved, enough to power 71 homes a year, in addition to 479,938 pounds of carbon dioxide were eliminated, the equivalent of removing carbon dioxide emissions from 42 cars annually. My point of this is that as we deal with this latency issue about inefficient information, trying to make better quality decisions, we need to start communicating in various ways, because different people will emotionally connect to different translations. These are all basic equivalences. But we often use these terms that may make good sense and be part of our, the dialogue that we have on a normal basis. But a lot of people won't have that level of kind of energy literacy. So being able to translate and communicate in accessible ways is a great idea. Once you have information, not only can you incentivize and encourage certain kinds of behaviors for individual consumers and households, but you also have a very powerful tool to allow you to do profiling, right? So cost-effective ways of figuring out how to go out and build business models to address a lot of the waste that we're venting into our atmosphere. So these are just some interesting ways, right? There is the example of using a utility bill, right? That you can find patterns. If you can aggregate lots and lots of utility bills, you can, and then intersect that data with information about, the size of a house and when it was built, right? Which you can get from various different public sources because of sales records. If you intersect those things, you can probably do a pretty good estimation on which houses have really old windows and are leaking energy all over the place. They become a very high quality candidate. If you can go to a customer and say, listen, this isn't some generic sort of pie in the sky sort of hypothetical example. This is your house. You're currently spending this. If you did this, this, and this is how much you saved. These are the financing options. This is about you. And by the way, you have these 5 different things you could do, and these are the lowest hanging fruit, and this is the order of them. There are, you can run around and take pictures of people's houses or get satellite images out of Google Earth. If you've got a winter picture, you can determine various different patterning on roofs to figure out obvious places that need insulation, or run around with infrared cameras and take pictures of houses on a cold night or on a very, very hot day and visually see. And when you go to a customer and you say, this is your house, right? See that area in red there? That is $195 per month of energy, right? If we did this with a payback of 8 months, after that, all to your bottom line, or finance it through this option, and we'll capture some of the savings you get, that's your house. This is your bill. That's a very different sales call than, getting a generic mailing in the mail with kind of a generic value proposition. This happened to me on Monday. And this is, I'm almost finished, like 2 more left. I know. I'm fun now. I don't know about you. So, this happened to me on Monday. It was really quite extraordinary. I got a call. And there was a nice Indian lady who was obviously calling from the other side of the planet in a very large call center. There must have, I could tell there's hundreds of people all reading from some sort of script. And she said, the government, the first words ever out there, the government of New York, for qualified people, is giving away free solar installations on your house. And I said, well, first of all, I know that's not true, and I'm staring at their website, but I'm curious to see where you're going with this, so go on. And they said, first of all, what's your monthly energy expenditures? Now, if they didn't know that, it would be great if they did. That would improve their business model. So I said, it's about, $140, a month for electricity, and about, $110 for gas. They said, okay, good. And they said, do you know what the orientation of your house is? And so I whipped out a compass, and I said, well, it looks to be about east-southeast. And they said, okay, good. And, do you have, what's the square footage of your roof? And I kind of gave them some number. And they said, what's your credit score rating? And I said, I don't know, but let's, for argument's sake, say something. So you take that, and you take the credit score rating, and she said, well, wait a second, you seem to be a qualified customer. Let me get you to talk to one of my supervisors. And so the supervisor gets on the phone and says, well, the trees at the southeast corner of your house, do you have any idea of how much shade they cast onto your roof at midday? And I go, what do you mean the trees? And he starts saying, well, the trees at the other corner, they look to be a bit tall. I mean, could we trim them back? He's staring. He's in Bangalore. He's staring at a satellite image of, by the way, that is my house. He's staring at an image of my house, describing it, and he's telling me that I've got an orientation of 170 degrees east-southeast, and that I've got a certain size, square footage of roof that can be covered, and he's got projections about what the angle of the roof is, and he's worried about the encroachment of the trees in the 2 bottom corners there in the back of my house. Wow! The next day, I get an email with this picture in it. And this I thought was really interesting. I would love, there's lots of ways to improve this business model, but I would love to give you some actual numbers here. In fact, my numbers for my bill. But, figures can't be choosy. Monthly power bill before solar. After solar, monthly power bill is about a third. My solar payment. So this is a financing option. This company will recommend highly qualified people to solar contractors in my area to come in and do this work, and link me up with a financing company to finance the capital investment. And telling me that I'm going to, even with that, have a monthly savings over what I currently spend on electricity. Wow. Information allows for very tailored, highly precise, individualized sales pitches so that people can make better quality decisions. This is another really fascinating example, and I really suggest you go to see this. This is a system that IBM built in partnership with the Central University of New York City. It's a live site, and it has a picture. This is only one section, but it's a bigger picture of the greater New York area. And all those little dots are solar installations. You can hover over them and click on them, and you'll get a picture of that particular installation. You'll get what its generation capacity is. You'll get which contractor installed it, if it's a government or commercial or residential. You can also get live data by clicking there, which will tell you that right at this moment, how much is being generated off of that system. Thousands and thousands of these things. Then you can in fact go into a different mode that says find a building. It brings up a map, you hover over, you can drill down to blow it up really big and pick any building in the greater New York area and hover over it, and it will come up, and I actually chose the United Nations here. I just did this live this afternoon. And it says the amount of electricity that you can save in this building, because it knows its square footage, and its coverage rate is $12,968. I can install up to 53.65 kilowatts of solar power on this particular building, and I can reduce my carbon emissions by 47,000 pounds a year, which is the same as planting 128 trees. Now, this has been built. This is just a data mashup. Can you imagine a map of the entire state of Connecticut for individuals or for contractors that they can hover over and say, because of your house, its orientation, it's the size of its roof, your current, the volume of the house, and you can extrapolate that from your current electrical expenditures, and then give that information both to the consumer and to a contractor to say, this is a high quality candidate for a solar installation, changes everything. Okay, there's of course package the incentives, tax credits. In New York, they're giving me $1,000 if I want to replace my furnace with a high capacity, with a high efficiency one. They'll buy back my old air conditioners, all kinds of things, as well as they're providing me with mobile phone apps that allow me to compare and contrast my electrical rates with my neighbor's ones, so that I can kind of gamify and compare and contrast how I do. And it shows you what the peak load, what the loading on the grid is at any given point in time. Lots of information out there. The problem is, my chief argument, there's latency in decision making. Consumers have very little actionable information. The price signal is by far the largest motivator, but it's a very crude one under current conditions. Energy decision making is abstract for the average consumer. Bills are once a month and largely ignored. And there's a lack of empowerment. Empowerment becomes a really big deal. Government incentive programs are not focused or optimized, and green building and consultant efforts aren't focused and optimized. We need to understand that conservation and efficiency and reducing waste is by far the highest payoff. We need to target where the biggest payoff is and communicate it effectively in a language that people understand. We need to communicate the price signals in a very individualized context, and communicate the non-price signals, because there are some of us that are willing to tolerate premiums over the raw price because we believe in driving hybrid cars or using solar power or whatever. And we need to communicate those things more effectively and efficiently. And that will allow us to make much more evidence-based policy making. Data analytics enable efficient systems. Governments improve policy making. Utilities make more efficient load balancing and promotions. Energy consultants make more efficient targeting and lower cost of sales. Citizens become more engaged, more in control, and can reduce electricity bills and then deploy capital against more productive targets. Builders can use evidence-based business cases and references and leverage predictive analytics to figure out where, in fact, to deploy their investments against the best potential returns. And energy brokers can lower shared risk barriers and do much more precise targeting to get better returns. And of course, financiers, including mortgage companies, suddenly have a data set that can be used to do much, much more precise risk analysis and risk mitigation, and incorporate that knowledge and intelligence into the entire banking and financing and insurance dynamic that goes around buildings and residential houses. Okay, Mark. Sorry about that.
So, well, you can imagine how long our lunches are. Just wait till you get him on a topic that he's interested in. So next I want to introduce Ron Arugio. He's Manager of Conservation and Load Management for Connecticut Light and Power Company. I may not be a strategist, but there was some method to the madness in seating him next to Doug. Mr. Arugio has almost 30 years of experience in energy industry, working in various roles with Northeast utility service companies. He's board member of Northeast Energy Efficiency Partnerships and is a board member of the Energy Efficiency Board, EEB. Mr. Arugio has a BS in mechanical engineering from the University of Massachusetts, licensed professional engineer in the state of Connecticut, and a certified energy manager with the Association of Energy Engineers. Ron.
Good evening. Let's see here. Perfect. Just so I don't forget who I am. Okay. Good evening. As Mark mentioned earlier, I was up at the in New Britain this today, going over the 3-year energy efficiency plan. And before I get into the presentation, I'll just give you an update. Governor Malloy had announced that he wants to make Connecticut the most efficient state in the nation, and the charge that came out of that was that the utility companies in Connecticut had put together a plan, a 3-year plan, to try to move and propel Connecticut to get into that #1 spot. It's based off of an integrated resource plan that the Department of Energy and Environmental Protection had put together. And the whole idea behind this was to actually come up with funding and energy savings that will actually make homes and businesses more efficient, whether they be new construction or whether they're existing and they could be retrofitted. And right now we're in the first day of a multi-day proceeding that's going over the economics behind all that, looking at what it costs to actually implement these programs, what it costs for each one of these individual measures. It's predominantly based upon energy efficiency. It is clean energy, but when people think of clean energy, they normally think of solar panels. We're not as sexy as that. No one really wants to go in and take a look at the insulation levels in my home, but it's actually the most cost-effective resource that's out there. It's on average about 5 cents to a kilowatt hour to deliver energy efficiency. Now, with regard to what does that mean to the average homeowner, everyone, whether you own a business, work in a business or whatever, everyone has a home, whether it be an apartment, condo, or a house. And one of the things that we've crafted is a program called Home Energy Solutions. And by show of hands, has anyone ever heard of that, or who has heard of it? Okay, that's good. Now, who's participated? Okay, I can still talk. So there's room here. Back in 2007, we got together and created a program that was looking at trying to air seal homes, basically using what we call a blower door to depressurize a house, essentially exaggerate the leaks in a home to try to find them. And then also take a look at, can we seal the ductwork within a home? What happened is that we took a look at that, and we took a look at the fact that traditionally we would do energy audits in home. We'd have someone go out and they'd walk through your house and decide what needs to be done. You need to replace your refrigerator, or you need to add more insulation, or your heating equipment needs to be replaced. Not the most efficient use of time, because you typically would generate a report that would be delivered to someone. It would sit on their kitchen table, and not much action would ever happen. What we decided to do was to actually marry this blower door technology with what was an energy audit, and we got clever and we called it an energy assessment, and we actually trained and certified firms to actually show up at the home, and what they would do is they would actually use a blower door to go through and identify the drafts and seal them at the time of that visit, and while they were there, go through and take a look at what other opportunities were within the home. And so what happened is that we now have companies that go out into people's homes. We have about 30 vendors now that we've trained that go out, and they will actually do a blower door, seal, identify where the drafts are, seal the drafts up in the home at the time. They'll install energy efficient lighting in the home at that time of the visit, and they'll also identify areas such as, do you need more insulation? Do you need more efficient appliances? And what's the status of your heating and cooling equipment? Does that need to be checked? And also, are window replacements an appropriate item? What has culminated with all this is that earlier this month we actually went down to Washington, D.C., and we were recognized by Energy Star as their Partner of the Year for creating this program. It is recognized as a leader in the nation, and it's now starting to be modeled by other states across the country. So we've actually come a long way from 2007 to where we are today.
Congratulations.
Thank you. What I'd like to do is try to tie what Home Energy Solutions does and what it could mean for you, but also what it means for the state of Connecticut. Mark had mentioned earlier Public Act 1180. One of the things that came out of Public Act 1180 was the state goal to weatherize 80% of the homes in the state of Connecticut. Right now, we're in the process of, we have a study going on to determine what is the status of the homes within Connecticut. And there's actually a survey going on that's being conducted by the Energy Efficiency Board. That's going to help inform what is the definition of weatherization, first of all, because we need to know what does a weatherized home look like, or what does that mean before we get there. But what we've done is we've actually determined, by looking at the housing stock and what we've done today, come up with an approximation of how we're going to get there. And this graph right here shows that on the current trajectory for the program plan as we have proposed, we will be able to hit that goal of weatherizing homes by 2030. There's roughly around 1 million homes that are what I would call market-based homes, and then there's around 400,000 or 500,000 income-eligible homes that we will be able to go through this. So we're well within our way to get there. We've done approximately 200,000 homes to date for over the past few years. We do approximately 20,000 homes a year. But what I want to do is I want to spend a little bit of time on what have we learned while we've done this, because this is something that may not be obvious to everyone. First of all, the graph on the left, and I apologize, it's not as clear as I would have liked to have made it, but the graph on the left shows what is a typical home use as far as where the energy is going. And if you take a look at the blue bar on the bottom, that's lighting. And if you take a look at the next level up, that should be the basically your heating and cooling, and that's the savings that's associated with air sealing. That's that blower door that I was referencing earlier. The next one up, the green bar that's there, is what we call duct sealing. As part of the Home Energy Solutions program, what we also do is we actually attach a device onto your ductwork called a duct blaster. Another clever name. And what this does is it actually pressurizes the ductwork to determine where your ducts are leaking in unconditioned spaces. So if you have an unheated basement, or if you have ductwork running through your attic, and the ductwork hasn't been properly sealed, when they put this device on it, what it does is it shows where that's leaking, and they can go in and put mastic on it to seal it off. And what that does is it keeps the conditioned air that either your furnace or your air conditioner has treated, and it makes sure that that air gets to the space that it was designed to go in, where you're living. So the next bar up from that is actually your hot water measures. The other thing that we do as part of the services that we'll go through and do pipe insulation on your water heating, and we'll also install low-flow aerators and low-flow shower heads. This reduces the hot water consumption in the home, as well as save water in the home, but it reduces the hot water consumption. So if you take a look at that bar, the graph on the left, approximately 80% of the savings that we typically see from a home come from that one visit. That visit will cost, depending upon how you heat your fuel, either $75 or $99. Oil heating customers pay $99, and gas and electric customers pay $75. The pink bar above that on the left is actually what we're seeing coming from insulation. Insulation is probably the most cost-effective measure that you can you can add on to a home after you've done all the air sealing that's associated with it. And then the other measure above that is just some changing out your heating equipment, what have you. If you take a look at the bar on the right now, what this is showing is that, well, what is the potential out there? And you can see that what we've looked at is that the housing stock that's out there, what else could we do? And the core services remains the same. We think we can get a little bit more core services. We basically have a goal for our vendors where we try to improve the amount of savings that they get out of the home that they go in, about 10% each year. So we're trying to ramp that up each year. But the majority or the lion's share of where the additional savings comes in is through the add-on measures, and that would be replacing heating and cooling equipment and doing more insulation. There's more insulation that could be done that's not presently being done. But what we did is we actually disaggregated that insulation block, the various levels of pink, to try to show that fact is the reason why insulation isn't done all the time is because some insulation jobs are just too costly to go into. And a good example is that if you had minimal insulation, if you had 0 or 6 inches of insulation, and yes, there are homes with no insulation in the ceiling, if you do find that, it's very cost effective to go in and insulate that up to an R40 value. However, if you had R30 already installed in the ceiling, the incremental cost to get there is more expensive, and the savings isn't that great. And so what ends up happening is that from a cost-effective standpoint or a payback perspective, it's not as attractive to the consumer. And so more often than not, that does not tend to get prioritized as from a replacement standpoint. What we did is we took a look at this another way. Okay, what happens with energy consumption in the home? And what we did is we took a look at, again, the bar on the left kind of shows what does a typical home in Connecticut look like. And this is a representation based on MMBTUs, or millions of BTUs in the home. We convert electricity from kilowatt hours to BTUs, as well as fuel oil or natural gas over into BTUs, so we could compare it all. But the key thing that this is trying to show you here is that the heating area, or the heating of and air conditioning of a home, is where the majority of the savings is going to come from, and that's where you want to focus your attention on. Lighting is still a very cost-effective area to go after, but heating and cooling is where you want to do that. And so you can address that one of two ways. You can address it at the source by making sure that the volume or the space that you're trying to condition is tight, so that way you don't need to generate as much hot air or as much cool air going into the space. And then the other thing would be to trying to address the actual plant that's performing that, your boiler, furnace, or your central air conditioning system. On the graph on the left, what we did is we took a look at, well, where are the savings coming from? And you can see that on the first bar on the left is lighting, and you can see roughly around 3 MMBTUs come from lighting. And again, I mentioned that is typically based is a service delivered through the core services. And then the next one you see that is roughly around an MMBTU coming from the duct sealing, and then there's around 6 MMBTUs coming from the air sealing. So all total, you have a little bit better than 10 MMBTUs coming from those core services, especially if you add in the water heating measures. Then you take a look, the next biggest bang for the buck is going to be the insulation, as I mentioned earlier. And you can see that our rebates and as well as the savings tend to coincide with one another as far as that's concerned. Now, what we did is we took a look at what happens with the, what impacts the customers from doing the add-on measures, because we have heating system replacements that I've talked about, we have appliances that can be purchased for replacement of refrigerators or things like that, central air conditioning, and then insulation. So what we did is we took a look at, well, what is the payback? And most people think that, well, windows is one of the first things you do, because windows are a great way to save. And you know what? They are very good to save, but they have roughly around a little bit better than a 10-year payback. Not the most cost-effective. But if you take a look at, and I apologize for the small font here, but if you take a look at wall insulation, is the one here on the bottom. A lot of walls that are either not insulated or very poorly insulated, and by increasing the insulation in there, you can see that roughly has around a little bit less than a 5-year payback. Ceiling insulation is another one. Again, I mentioned going from no insulation up to R40. Again, is roughly around 6-year payback. And then changing out your hot water heater if you're using electricity is a going to a heat pump water heater would also be very cost effective. The other thing that this chart doesn't really reflect well, though, is the fact is that you got to take a look at what is the cost for fuel. For example, on this chart right here, oil looks much more cost-effective than natural gas, which is true. If anyone who's opened up their oil bill lately knows that the price of oil is not all that low at the moment. And so what happens is that means that the higher cost fuel is going to have a better payback. The other thing this doesn't consider is the fact that if you had the ability to switch fuels going from oil to natural gas, that's also going to influence your payback. But the key point here is that when you're taking a look at replacing equipment or upgrading, either adding or replacing, you want to make sure that you're looking at what is the most efficient equipment that you can operate at that time. There's incentives available for you to change it out and go to a more efficient piece of equipment, and that is the prime opportunity from when you want to replace it. There are multiple resources out there to help you as far as that's concerned. On the appliance side, there's a site that is available on the Energize CT site that you can link to called Top 10 USA, and that lists the top 10 most efficient appliances in a variety of categories, and so you can find out what is available to you that way. If you're looking at replacing heating or cooling equipment, you can call 1-877-WISE-USE or go to the Energize Connecticut website and look for resources there. But there are incentives and ways to help you improve the energy efficiency of your home, and I encourage you to take advantage of it.
Thank you. All right, let me switch. Well, thank you, Ron. Stick with us, people. You're going to realize that this really is a very comprehensive team, and I'm very excited about it. And as I sit here and listen, I think we're true to form as building energy innovators. Next, I want to, please let me say, I'm not sure if I mentioned before, that Ron runs conservation and load management programs from inception to delivery, both for CL&P and for Yankee Gas. So he's really tackling utility delivery in both aspects. So next I want to introduce Mark Schiller. He's Vice President for Business Development and responsible for Global Strategic Outreach and Business Development at Proton Onsite, another innovative local Connecticut energy solutions company. He's a bachelor's degree in science and in petroleum engineering from Tulsa University and an MBA from Oklahoma State University. So if I can crystallize what is Proton Onsite, they're focused on the utilization of excess renewable energy, specifically coming from wind, solar, and hydropower, for the production of hydrogen via electrolysis, and to be used to power homes, commercial buildings, new energy markets, such as the fuel cells and microgrids we heard about at our last session, and very specifically fueling stations for transportation, for hydrogen fuel powered electric vehicles. So I'm very excited to introduce Mark, and I'll let him take it once I advance his slide. Thanks. I'll take that.
Thank you, Mark. So a lot of people ask me, especially when I come and speak at a forum like this that's environmentally focused, what's a petroleum engineer doing in this room? And my answer to that is I've come from the dark side, and I now work for a company that is very environmentally focused. I did spend a big part of my career in big oil, but I was always working in areas that were looking at new energy technologies and looking for ways to expand the portfolio within the big oil companies. Now, we know gasoline is here to stay for a while, so it's never a core part of their business, and that's when I started to look at other ways that I could influence what's happening in the environment and do some other things that I thought would be productive for the long term. So what I'm going to speak to you about today, a company called Proton Onsite. We're in Wallingford, Connecticut, and the fundamental focus of what we do is hydrogen generation. We do it through a process called electrolysis, where we basically split water, H2O, into hydrogen and oxygen. There are a lot of traditional industries around the world that use hydrogen, have for a long time. 95% of the hydrogen used in the world actually goes into refining. But their power plants, the meteorological industry, semiconductor industry, they all use hydrogen. So when our company was founded, we were taken in by the dream that there would be hydrogen fuel cell cars by the year 2000, and we know how fast that came about. So what our company has done is we've evolved into the traditional markets where we've given end users the ability to control their own inventory of hydrogen by actually making it on site. We have a portfolio of products, and I'll get into that, but basically we're a turnkey solutions provider with products, installations, engineering support, founded by 5 people that came from big corporations to develop this company into what is now a worldwide sales and service organization. We're in 80 countries around the world, have over 2,000 units installed around the world. We're on every continent. And the driver behind that was there is a big movement towards energy consciousness around the world. And there's a much bigger political will outside of the U.S. That's really driving it. So where we're focused now is into some of these new hydrogen energy markets. That's where the sizzle is, both globally and domestically, around fueling, power to biogas, and renewable energy storage. So some of you are asking, well, all right, how does all this relate to buildings? And how is this going to help me as a developer do things with homes? And I can tell you right now, I probably don't have an answer for you. Because the way this evolves, and historically how some of these great technologies have evolved, is from big business, and then it makes its way down to the consumer. So what we know today is big business is using our technology because it helps their manufacturing facilities operate better, they have control of their supplies. But what we do see coming, and we have different companies we're working with strategically around the world, is they're now incorporating the bit of technology that we have into something called a fuel cell. And I think you mentioned in an earlier forum that you had Fuel Cell Energy here talking about fuel cells. Well, now what they're doing is they're incorporating not only the hydrogen generation piece, but the fuel cell into one box, and they're doing that for residential applications in Europe. That will eventually get to this country as well when the political will is there to support it. We do have an issue in this country with we're a slow mover compared to the rest of the world in terms of adoption of renewable energy solutions. If you take a look at what's happening in Germany right now, they're shutting down all of their nuclear plants, and they're converting that all to renewable energy. Well, the grid isn't ready to accept all of that renewable energy, so what are they going to do? Well, they're looking for energy storage solutions. The technology that's in favor right now, and this is a good thing for Proton, a small Connecticut company, is electrolysis appears to be the solution of choice for energy storage. Well, the next question is, where are we going to store all of that hydrogen that we're making? Well, in northern Germany, they have a number of underground salt caverns that can store gigawatts, thousands of gigawatts of energy in the form of hydrogen. So what they're doing is they're leveraging the wind assets in northern Germany, multiple gigawatts of installation, growing, and they're making hydrogen, and they're going to store it in these salt caverns. And then you can use it as a fuel later for what is an evolving hydrogen fuel cell car market. You already have one automotive OEM that's opened up a manufacturing plant and is putting hydrogen fuel cell cars into Europe today. All of the other automotive OEMs have said that by 2015, they will put these cars into the market, not only domestically, but internationally. So you've got this growing momentum starting in another part of the world, making its way into this country. You're going to start seeing devices that will go to the homeowner who is looking for an alternative to what they're doing today. Rising energy costs. How can we control our energy costs? You heard a lot about devices in the first presentation and a lot of ways to monitor and improve what you do with your energy. Well, this will be another tool to help you manage your own energy use. Just to show you a few pictures of what a hydrogen station looks like, the lower picture here is actually at our facility. We've had several automotive OEMs. Those cars right there run on hydrogen. No gasoline goes into that vehicle, and people say, well, what's the range? The range of those cars is 350 miles. The next question is, well, how long does it take to fill? It takes 3 minutes to fill those cars. So it's a real consumer product, and it's being adopted internationally. A couple of other stations, you see a bus station in the upper right, and then the one on the left, upper left, is a station that we've done in Germany. High-profile automotive OEMs are interested. This is another form of energy storage, but I'll bring it even closer to home. Those few pictures you see in the top row here, that is a home fueler that we put at a gentleman's house in Miami, Florida. He has solar panels on his roof. He uses those solar panels to power that device, makes his own hydrogen, and fuels that GM hydrogen fuel cell car. Complete control of his own energy use in one form. Now, again, you're asking the question, well, that doesn't help me as a builder. Well, it is when you have developers looking at neighborhoods at how they can incorporate this technology to make a new development attractive to a potential set of buyers, where they might put one of these as a neighborhood station to fuel multiple hydrogen fuel cell cars in that development. Number of different people from around the country and internationally have talked about developments like that. So the next question I get is, well, how much does something like that cost? Well, that is not ready for the consumer today, what you see in the top row. It's too big, and it still uses too much energy. So what we have in the bottom row here is the next thing that looks like a mini refrigerator. That's what the next generation of it will look like. Most people can fit that in their garage. And if you can't, it's easy enough to put outside. That's not much bigger than an air conditioning unit that you see outside a house. And again, it's another way for the homeowner to have control of his energy use. So what are the critical needs for energy storage? We know renewable energy is growing worldwide. We have regions of this country. You look at California, you look at the upper Midwest, wind is very big. You look at the warm areas of the United States, Florida, Texas, Southern California, solar is big. All forms of renewable energy, a lot of energy is made. The grid in the U.S. can't take all of that energy, so it's wasted, it's dumped. So we need forms of energy storage. The technology we have can take that excess energy, make the hydrogen, store the hydrogen for later use. So my final comment here is on emerging energy markets, and they're real. We know energy storage is critical. It's one of the most important things we're doing at Proton today, is looking at what will the portfolio of solutions need to be for the future, not only for big business, but also down to the consumer level. Scaling the technology. When you're talking about multi-megawatt wind turbines, you need a device that can take that much power in to create the hydrogen, so scaling is important. PEM electrolysis. I won't get too technical on what PEM is. Think of it, it's an electrochemical cell that converts that water into hydrogen and oxygen. That's the technology we have at Proton. It's become the technology of choice in the last 2 years because of its ability to react to the intermittent load of wind or sun. The wind doesn't blow all the time, but when it does, you better be ready. This technology reacts in less than a fraction of a second to that input load. And then finally, it's becoming more viable. We see the cost of wind turbines coming down. We see the energy density of solar panels improving and the cost coming down. So we see that it's becoming more viable around the world. Thank you very much.
Okay. Okay, so what's really exciting about hydrogen is that it is a truly renewable energy source, and you can deliver power from it without burning a fossil fuel. It's something that we constitute. And what took me a while to realize, especially in large wind, not the small wind vertical access turbines, but especially the offshore horizontal access turbines and hydrogen power, is that there are peak load times when the grid can't accept or use the power that are being generated from renewable energy sources. But these the technology with hydrogen is, and their electrolyzers and storage capacity at high pressure, is they're able to capture and store that power that would have been dumped otherwise. And what's very encouraging, an economic crucible that I picked up tonight, is you're hearing that Mark's firm is deploying a lot of their technology to Germany. So we've heard a lot about the solar panel dumping here and our tax dollars being used to subsidize foreign, specifically Chinese companies that were buying their panels. But this is a case where Europe is buying Connecticut technology to store the excess power they're generating from renewable resources. So it's very exciting, I think, to see how it's coming full circle.
Yeah, Mark, if I could just add to that, 75% of Proton's business is international today. So small company, 80 employees, 75% of our business is outside of the U.S. and growing.
Is the oxygen released to the atmosphere?
It is, but some applications will capture it as well. It really depends on the end user.
So we'll preserve a couple minutes for Q&A at the end. I want to get to Mark Simon. I'm really excited to have him here tonight. I'm really excited to have him here in New Canaan specifically, and I'm hoping that some of the legislators that are here tonight will think of his firm when they commission the next town building, school, library, and so forth. Mark is one of the most prolific, sustainably focused green architects, if you will. A Yale graduate, founding partner of the 75-person firm, which is big, very big for an architectural firm. And without stealing his thunder, one of his mantras, looking at sustainable and the energy footprint of a building, is to first reduce the energy appetite of a building, 2, make all systems as effective and efficient as possible. And I think, Ron, you would concur that that's the right way to go. And only after number 1 and number 2 do you employ renewable energy sources. So with that, I'd like to introduce Mark Simon, architect.
Thank you.
Can you advance your slide?
Okay, I'll advance. There I am. Hi. Thank you for staying. Mark just basically told you my lecture, gave you my lecture. So here are the slides that go along with that message, okay? And I can't blame him. I'm going to show you 4 radically different buildings that we've done. This is an underground house as it was originally done on the lower slide almost 40 years ago. And that's it on the upper slide a year ago. It still works. It's built into the side of the hill. It has 18 inches of dirt on it. This is Croon Hall at Yale for the forestry school that we did in collaboration with Hopkins Architects out of London and an international cast of consultants from literally all over the country and all over the world. It's a LEED Platinum building. This is a house I completed a couple of years ago in Northwest Connecticut. It's about 8,000 square feet. It uses logs as a sun device, shading device, and it fits into its hillside. And then lastly, this is a school I finished just this year for a science and math building for Berkshire School in the southwest of Massachusetts in Sheffield that is highly sustainable. It's about to be awarded LEED Gold, and not only the building but its site is sustainable. It uses very little electric lights, among other things. So what's the same about all 4 of those buildings? The same is that we've used the same approach to them that Mark actually mentioned, and we've been using it for 40 years, and not much has changed in this. It's really amazing. I mean, everybody thinks, we've heard a lot tonight about what's developing and changing, but our basic approach has not changed. Initially, we first think about minimizing the needs of a building when we're designing a building, trying to have it have as low an appetite as possible for energy. Secondly, we try to optimize the use of its systems, make them as efficient as possible, whether it's through using information, using better heating system, and so on. And then finally, we start to look for green energy sources, whether it's photovoltaics, looking to proton next year, which we will. But that's the way we've always worked, and that's the way I think we will continue to work no matter what comes along. And this seems like a no-brainer, but I can't tell you how many clients come to us and start backwards and start thinking first about, they come and they say, I want some sort of solar collector in my house. And they haven't thought about anything else. Or people who want renovations and say, I want solar collectors in my house. And I say, have you looked at the insulation? And they haven't looked at all. And I go and look at the insulation, and they don't have any insulation, and they have very little. So that's lesson number one. Lesson number two. This is a breakdown of the energy that is supplied and the energy conserving methods that we used at Kroon and the various percentages of them and the amount of energy they saved or provided. And this is the cost of those various elements. And you'll see that, first of all, this tells you what I just told you, which is that there are some elements that, like the photovoltaics, that are pretty effective, and they provided whatever it is, 24% of our energy, but they also took up more than half of the cost of all those energy methods. But that's not the message here. The message here is, to be sustainable, you have to use many, many, many different elements in a building, and we already heard that from Ron. But you can see here, and in fact we saw a chart that was very similar to this. It was all ticked off that you showed. Another way of looking at this is that your passive elements, the elements that reduce the energy appetite, generally are the least expensive and do the most work. And it works back up the opposite way in terms of optimizing functions in active systems. Okay, so that's message two. It takes a lot of different methodologies to make a green building. And message three is that every building and every location is really different. Now, very often we will work with a client to look at, and this is again very similar to what Ron was talking about, to look at lots of different techniques that we might consider for their building and look at their costs and the time to payback. And again, this is very similar to what Ron's been doing with existing buildings. In this chart, the lower left corner are kind of the no-brainers. Maximizing your daylighting in an effective way, enhanced insulation, and orienting your building in the right way, and so on and so forth. The farther you get to the upper right, the slower the payback, the more expensive the element, the more unlikely we're going to do it. But what's interesting here is that this is for the Northeast United States, and if you go to the Southwest United States, a lot of things move around. That's a broad example, but it's also something that happens from one block to another, because you may not have the right orientation available to you. You may have for instance, we've been doing geothermal pond loop systems that are very cost-effective to do. Rather than drilling wells, we put loops or radiators in ponds and exchange energy with those as a very low cost. One house will have a pond, another house won't. So these things are very specific to location. They're also specific to use. And we do an awful lot of institutional buildings, and a lot of our institutional clients, we've done a lot of LEED buildings. We're actually doing a living building challenge building right now. But when our clients who want to do a sustainable building come to us, we try to go through very carefully what their environmental design priorities are, because they're not all the same from institution to institution. These are all environmental issues. These are all environmental sustainable issues here. Occupant health and well-being, making an institution look like it's green to the outside world, the energy efficiency and the cost savings, the reputation of the institution, LEED certification, carbon footprint, and so on and so forth. But from institution to institution, these priorities change. Oops. And we have to be very, very careful with them and decide with them what they want. And you'll see that makes some of our elements in these charts more important than others to a particular institution. These are the elements that would be important if we were really, if getting a LEED certification was really critical. But if the institution just wants to be known as being green without getting LEED, there's another bunch of things to look at, because those are things that you can show off, that you can see. Or if you just want a really healthy place for your occupants, then you get to start looking at a whole bunch of other elements. So not only is each place different, but each client is different. And we can't assume that one size fits all, that one approach fits all. You have to dig deep and really look at the situation very carefully. So thank you.
Well, thank you, everyone, for sharing my enthusiasm for this topic, or these topics. You all get extra credit for staying with us tonight. And just think how far we've come in the last 42 years since Earth Day was conceived and inspired things like the EPA. And, I mean, how perverse is this? We're here tonight with an executive from one of the largest utility companies whose responsibility is energy conservation. I mean, who would have thought in 1970 that we'd be there now? And we'd have scientists at IBM focused on energy disruptors and deploying their strategic thinking so that we can build better buildings like those that Mark is developing, and that we have a carbon trading program and RGGI, the Regional Greenhouse Gas Initiative program, that actually harvests literally dollars to be used to underwrite projects like what Proton Onsite is doing. So I'd like to open the floor to a couple questions while we have what are literally a world-famous team of thought leaders in the building energy science field with us tonight. Doug.
I just wonder what you guys think about the whole concept of natural gas being a bridge to renewables, or whether we should be abandoning that and just trying to go straight to renewables as soon as we can.
I'll start, because that's a very hot topic right now. In Germany, they've got a program right now called Power to Gas, and what they're trying to evaluate, and it's very much in the evaluation phase right now, is using renewables, wind primarily, to make hydrogen and storing that hydrogen in a natural gas pipeline. There are a lot of pipelines throughout Europe where it could be stored. And the question is, well, how do you get that hydrogen back out if it's specifically for a hydrogen-only use? That's very challenging. The approach right now, and the thought right now, is that based on the small percentage of hydrogen that would be in that natural gas pipeline, you could still continue to just use the natural gas, and it wouldn't have any impact on how that natural gas burns and the different uses that it has. However, in Germany, and I use Germany because they are a leader in this area, Volkswagen has a very big lobby in Germany, and they have a lot of natural gas cars on the road. And they have some very, very strict guidelines on what percentage of hydrogen can be in that natural gas for their car to run the right way. So there's a big battle. And I'm not sure how it will turn out. There's a lot of evaluation going on. There are a few power-to-gas projects right now. We've actually explored the concept in the U.S., in Hawaii. They don't make any energy in Hawaii. So we've explored that concept there, and what we found is that there are some, in the U.S., there are some very, very big regulatory hurdles to overcome, much like any disruptive technology. So it is a concept that's being evaluate it, but I think it's still a little bit away. I'd rather store it in a salt cavern.
I guess, you want me to speak on that too?
Oh, Ron, would you? That would be great, yeah.
Yeah, just to
Hold
add
that
to
thought.
that, I tend to look at it, there is no silver bullet here as far as what's the right way to go, but Connecticut has more than half its homes heated with fossil fuel oil right now. In Seal Keys area in particular is better than 60%. And natural gas is a good way to go out and gain efficiency, reduce emissions, and attack it from that angle. But ultimately, as I mentioned in my presentation, the best way to attack this is to make sure you reduce the demand so you don't need to use as much. Natural gas may be the source you use to heat, but you want to make sure that you're not using as much as you need to because you want to reduce that.
Right, there's a lot of externalities with how you get the natural gas.
Agreed.
He gets an A for picking up on externalities.
The economist in me is, railing against some of this because the cynic in me is saying that, making this big push to switch to natural gas because it's cheaper. And we figured out ways of extracting it more cost effectively, and that we, especially in North America, have developed certain patterns of use, whether it's the way that we architect our cities and suburbs, and the way that we build arteries, the kinds of cars we drive, et cetera, that I think are going to actually put us at a collective disadvantage with respect to the competitiveness on the world scale, on the world stage, as the various different environmental constraints are kind of imposed upon us by the planet, because at the end of the day, the planet's going to win. And I do fear that our increasing access to very, very inexpensive energy is suggesting to us that the way to attack the problem is by just putting more energy into the system instead of doing all the things that our utilities are wonderfully encouraging us to do in terms of figuring out ways of using what we have much more efficiently. And I am frustrated that it's an artificial marketplace, and all those externalities are not priced into it, and I really wish we would have political leaders that had the courage to perhaps rebalance the way that it funds itself and reduce, take funds out of current taxation capture and reassign them in ways that balance the marketplace so we can make some better quality decisions. But once again, as a consumer, I feel a guilty pleasure that I have access to cheap energy, so I'm a hypocrite.
It's a pretty big house you have there, too. We saw in we had we keep coming back. We get people excited about fuel cells and microgrids, and then we sort of get off track with discussion about, well, natural gas, it's a bridge. Why are we going to be complacent and just accept a bridge as opposed to going to pure renewable energy source? And I think Mark Schiller was being very diplomatic, and he would not fight you on the suggestion, which I think you were implying, Doug, is can we bypass natural gas? What's really elegant about hydrogen and what's happening in this electrochemical reaction, this fuel cell energy box, is you plug it into your Connecticut, your Yankee gas line, but it's not using natural gas. It's going to reform that or break that down, strip the methane, and get the hydrogen, and then run off hydrogen. So it wants to be pure and natural, and with Proton On-Site's devices, they're synthesizing, they're generating pure hydrogen from renewable energy and bypassing the need for the natural gas bridge. So,
You're hired.
Okay, thank you. I told you it was a nonprofit, but in the middle there, do you still have a question?
Sure, I do, yeah. I'm Heather Lauber, I'm an educated resident, and so I'm just wondering if you can help me through this holistic question that I have. So I'm going through, and thank you everyone for giving us information tonight. I'm literally living through the audits and the upgrades, and so as a consumer, I've got all this detail in my head. So we've gone through the energy audit, we've spent a heck of a lot of money on heat pumps and solar PVs, and the insulation guys are coming next week, and there's holes in my house and wiring coming out, and I hope it turns out okay. But that was about $60,000 out of my money. So I'm one of those premium customers who's willing to take the leap of faith. But my next step question is, I'd rather not live on the grid. Why do I need the grid? So my question for Mark would be, how can I get there? And how can we work with the utility companies in that process and not have it be such a political process? And then Doug, I've been in corporate social responsibility for the last 11 years. Where I go from a traditional person working in a company wanting to get people in companies to do more of the right thing, to evolving them to being more savvy in energy. They're so good at giving away dollars and gifts in kind. But that next leap into the environmental realm seems to be huge for my consulting business, a huge leap of faith that they're not willing to take. So I'd be interested in knowing, how can my home be so smart that it doesn't have to live on a grid? I can walk in and it says, "Hi, Heather," lights up my house and do all these neat things that information technology can do. But how do we also get companies to believe in this? Holistic question for everyone, I guess.
I've been working on sustainable buildings for 40 years. And we started in the 70s because we had just been through the oil market. And we had a lot of clients who were concerned about energy. By the time we got to the mid-80s, nobody wanted solar collectors. Nobody talked about solar collectors. People would grumble about having to put thermopane windows into their houses, if you can imagine that. They grumble about the extra cost. I agree. It comes down to economics. It comes down to being practical. It comes down to being pragmatic. And I think you have to teach people that it's in their self-interest and convince them somehow that it's in their self-interest to do these things, which I think the people in this room generally understand because they see a bigger picture rather than next month's payback. We do a lot of work for institutions like Yale. Yale recognizes that when we build a building for them, they're going to have it for a long time. And so they're willing to put extra money into it. And literally, they estimate that it costs a typical college 4.5% of the original construction cost every year to maintain it. And they're working to drop that down to 3.5%. You can do the economics, but it pays off in the end. They are willing to make these very durable buildings. But if you're talking to, we were talking about this when we were making a sandwich out there. If you're talking to a developer who's going to sell the building next year, all he or she cares about is what it looks like for a year, long enough to keep the rest of their sales going. And that's a very different economic picture. It comes down to economics. And, we get back to the late 20th century and the early 21st century, and suddenly everybody's interested in saving, and they're all desperate to make their homes super insulated and so on and so forth.
Do you think there'll be a tipping point at which that economic pain is great enough for companies and larger institutions to change?
They have to see, well, if they have a long-term view of things. I'm still in a state of shock about Bayer in West Haven. Yale University bought the Bayer campus. I don't know if you're familiar with this. They bought the Bayer campus for $100 million. When they bought it, they announced that they were getting it for 10 cents on the dollar, which means that Bayer had put in about $1 billion into the campus. Whether they actually put that cash in, that was the kind of value that Yale saw in it. Bayer had been there for 15 years, 10 years. I don't understand the payback, but there had to be something with taxes that made that reasonable for them to put all that money into the place and then to leave. The same thing goes for investments in being sustainable. I think we need help from the government. We need to somehow make it economically viable for these things to happen. but we also have to make people think about the long term somehow.
Yeah, so here's what I'll add to it, because we're a disruptive technology, and we're always looking for how do we get this technology into a broader marketplace. The biggest challenge we have in this country, because I'd love to be off the grid myself, and you're looking at a former oil guy, okay? I would love to be off the grid. The biggest challenge you have in this country is energy is cheap. Compared to the rest of the world, energy is cheap here. So what's going to motivate companies, and I think it's to your point, long-term view, but what else is going to motivate companies to come up with solutions that will take you off the grid when energy is cheap? It's a battle. It's a constant battle.
And beyond the LEED certification that you're familiar with, Leadership in Energy and Environmental Design, yet another group, German-based, Passive House, and my co-chair of our committee, Elizabeth DeSalvo, architect here tonight, and former employee of Mark, is a Passive House registered architect. So I think you need two meetings, one with Elizabeth and one with her former boss at Centerbrook. Is there another question in the back?
Did you want to?
Yes, sir.
Yes, to Doug. I was wondering, he talked about individual generation for the residents, and he talked about super batteries, and talked about smart thermostats. I wonder if you could bring energy into the home at off-peak times to be used at peak times.
Well, sure.
But not a way to store it.
Yeah, so that's, of course, the biggest challenge we have with generation and electrical distribution today is that we've had to design a grid to deal with peak loading, right? We've got these big plants, especially nuke plants, that are spooled up, and it's difficult to adjust them in an economical way to the kind of loading that we have on the electrical network. You know, we had our headquarters building in Toronto when we built it. We had a very interesting billing arrangement with Hydro Ontario. They would actually charge us some coefficient, it was some number, multiplied by the peak utilization on the highest day of utilization in a month. And that was, all energy outside of that peak loading for us was basically free. And we ended up doing, really wild things like we had an Olympic-sized swimming pool in the basement that we would freeze as an ice cube overnight because the energy we use in the middle of the night off of peak load was basically free, and we turn around and take the energy off of that and deliver it against our peak loading.
This is diurnal cooling. For desperate for a vocabulary word tonight, but it's called diurnal cooling.
So, I think you're right. I think the issue is, one of the most important things we need to do is figure out how to deal with the peak loading issue, because that's a real constraint in terms of centralized generation. And my supposition is that an awful lot of that has to do with storage, because distributed generation, especially the renewables, solar and wind, you can't time the access to of that to peak loading, although there is a high correlation between solar capture and peak loading. This is typically 2 o'clock in the afternoon, right? Yeah. On a business day. So solar often has this peak generation capacity. So I think solar, both the solar thermal and solar voltaic, are kind of the most direct offset generation capability. Outside of that, I think that the real question that needs to be solved, the innovation that's happening, is around storage. And I'm suggesting that there's liquid metal batteries that some guys up at MIT are working with. There's hydrogen storage. There's flywheels. There's air pressure. And I think one of the most economical and flexible ones is going to be the fact that we're going to have millions of high-capacity distributed batteries that are going to be sitting all over the place. And we need to develop grid technology that allows us to put stuff into them and pull stuff out of them in order to deal with that.
And hydrogen would be one of those batteries, hydrogen storage.
And there's also thermal storage too, which we actually incentivize and have done many projects throughout the state where customers actually build ice and then during the nighttime and use that and take that off during the daytime to shed their peak. But Mark brought